Welcome back, matriculants. Right, so welcome to example number 3, right, for graph interpretation. Right, okay, again we have sketched below is the graph of f, right. The derivative of f of x is g of x, right. Okay, so we have on screen, right, basically a sketch of f of x, and we recognize f of x to be a cubic function, right. But we are not given the sketch of g of x, but we are told that g of x is the derivative function. Okay, right. Okay, so we have determined the value or the values of x, right, such that first of all we're looking for f of x minus g of x is equal to 24, right. So let's go back to our conditions, right. You can see that that one is speaking to this condition over here, right, where we said that whenever we see something like this, right, especially when we see this equal to k, right, some constant, we talk about the distance, right, from f to g being equal to k, right, where the first graph that they mention, right, so f is the one on top. Okay, so if you're looking at a vertical distance like this, right, that is going to be the y value of f, and then that's going to be the y value of g, and we want f minus g, okay, that distance, to equal this value k. Right, okay. The second one says f of x divided by g of x being less than 0. Okay, so that was not part of the primary conditions, right, that they want you to know, but I did mention it on the side, right, as something that can be asked. Okay. Okay. Right. So by now you should actually get sort of like the gist of this, right? And notice that in order for you to be able to answer these questions, you need to have the function g on the graph as well. Okay. Right. So we are now going to say, okay, going from calculus, right, we know that here at the stationary points, right, where we basically have our gradients equal to 0, right, those 2 points, okay, that is where we are going to have x-intercepts, right, for our derivative function. Okay, so in other words, over here it's going to share that point. Okay, right, so let's draw in the derivative function. If f is cubic, the derivative function is obviously a parabola, right? So let's see, right? So what is happening on f, right, in terms of gradients just before this x value? Well, f, right, has increasing gradients, right? So which means that our parabola has to be above the x-axis over here. Okay. Now what happens after this x value, right? Well, in terms of gradients, we've now gone past the gradient of 0, right? And now the gradients are decreasing, right? So because the gradients are decreasing, the graph of the derivative function, which is g, has to then be below the x-axis all the time. Okay, so it's going to go, because we know it's a parabola, it's going to turn at some point until it gets there. Okay, now what's happening in terms of gradients on f? Well, again, the gradients on f are increasing, so g has to then now start being above the x-axis again. Okay, maybe not the most accurate sketch of g, but there we go. All right, so let's go. Right. What do we need to fill in over here? Well, we're looking for distances, right? The first question, we're looking for distances, right? So which means that we have to be concerned about points that we can figure out, right? And look at their y values, right? So if you look at this point, right, try to think to yourself, is it necessary for you to find this point of intersection? Map it for yourself. Look at the y value here. Try to imagine it, right? So if that's a y value of 16, this is something less than 16, right? So that distance from there to maybe, let's say here, it's definitely not going to be 24 if you eyeball it, right? Because that's already a distance less than 16, okay? Right, so maybe that distance can actually come from here, right? So let's try to figure out what is the y-intercept, okay, of the function g, okay. Right, so there's going to be no easy way for us to figure out this y-intercept here, okay, for the function g, right? We have to find the equation of f, okay, and then from there differentiate it to get the equation of g, okay. So let's do that, right? So we're going to say solution. Okay, the first thing we're doing is we want to find the equation of f. Okay, right, so what do we have on f that can help us to find its equation? We have two of its coordinates, right, in terms of its x-intercepts. Okay, so we can write down the skeleton of f, right, similar to that of a parabola, right? We know that it's going to have some a value, right, which we need to calculate, and then it's going to have three factors, right? So x minus x1, and then x minus x2. Just move this. Okay, and then it's going to have a third factor, x minus x3. Okay, so if this was a parabola, it would have ended over here, right? But now this is a cubic, so it has three different factors, right? And we know that these x1, x2, and x3, right, are basically the values of the x-intercepts, right? Okay, so we need to notice that two of these factors have to be equal to each other because we have a repeated factor over here, right? We have a x-intercept that is also a turning point, right? So it needs to show up twice over here. Okay, so let's do that, right? So we're going to have a, right? You can think of this as substituting, right? Or you can immediately start changing the signs as you move from the x-intercepts into the factor, okay? But let's show it as if it was substitution, right? So you have x minus, right? And this first one is minus 2, okay? Then you're going to have x minus 2, and that needs to show up twice, okay? So simplifying, this is still f of x. We're going to have a, and then we're going to have x plus 2, right? Let's start multiplying this out. We're going to have x squared minus 4x plus 4. Okay, so we're going to have f of x is equals to a, and if we multiply that out, we're going to have x cubed, right, for the first one. Then we're going to have minus 4x squared. Then we're going to have plus 4x. Then we're going to have plus 2x squared minus 8x. Now you can't see anymore. Okay, there you go. Right, so where were we? Positive times negatives. Negative 4 times 2 is 8. Okay, so last one, plus 8. Okay, so collect like terms. This is still f of x. Okay, you've got x cubed, right? We've got a minus 4x squared here and a plus 2x squared, right, which is going to give us a minus 2x squared. Then we've got a plus 4 minus 8, which is a minus 4x. And then lastly, plus 8. Okay, so now we need something, right, a coordinate to substitute in here to calculate the value of a, and usually it is recommended that you substitute a coordinate that has a y value of 0. Okay. Right, just pardon me, right, I just made a mistake there. Let's just correct it. Okay, I was looking at this coordinate and I had written it down incorrectly, right? So basically I said over here that in order to calculate A, you need to substitute a coordinate that has a y value of 0. I meant to say an x value of 0. Okay, I'm pretty sure some of you noticed that mistake over there, but I just fixed it. Okay. Right, so we're going to say over here now that we're going to substitute, right, point C with the coordinate 0, 16. Okay, so which means that the 16 is going to go to the y position, and then we're going to have A, and then we're substituting an x value of 0. So you can see over here, this is going to die, this is going to die, this is going to die, leaving you with just a plus 8. Okay, so basically what we have now is 8a is equals to 16, right? So then therefore, if we divide both sides by 8, a is going to equal 2. Okay, so now you go back and you substitute the a again, right, to get your f. Right, so now you're going to say sub a value. Okay, so then therefore f of x will equal 2 times x cubed minus 2x squared minus 4x plus 8. Distributing gives you f of x is equals to 2x cubed minus 4x squared minus 8x plus 16. Okay. Right, so if we now reference the diagram, right, you can see that makes sense. Y-intercept at 16, y-intercept at 16. Okay, but we were not really interested in just finding the equation of f, right? Remember that we were trying to find the equation of g, which we were told is the derivative of f, right? So that we can find out where does this parabola cut the y-axis. Okay, so now we're going to do that. Okay, so find, just bring this up. Right, so now we're going to find the equation of g. Okay, so we then know that therefore g of x is equals to f prime of x. Okay, so then differentiating that equation, we'll get 6x squared minus 8x minus 8. Okay, right, so that is the y-intercept over there. Okay, so we can just write here minus 8. Right, so now let's look at that distance. Right, so from the top, which is basically f, right, let's do it on the calculator. 16 minus negative 8, right, that gives you a distance of 24 units, which is basically what they wanted you to find over here. Okay, so whenever you see this type of situation, always try to concentrate on any of the vertical distances that you can calculate, right? And usually, I'm not saying always, usually it's this distance of the y-intercepts. Okay, right, so to write down the answer, we're going to write here, therefore, f of x minus g of x is equals to 24 when x is equals to 0. Okay, remember that the x value there is 0. Okay. Right, so now on to part B. Right, so part B, we're looking for f of x divided by g of x being less than 0. Right, so let's think about the first condition where that can occur. Right, if we want it to be less than 0, we basically want them to be on opposite sides at any given time, right? So we're going to have a positive divided by a negative, right? That's one condition. Or we can have a negative divided by a positive, okay? Right, so let's first try to see if we can locate this situation where f is positive but g is negative. Okay, grab your ruler. Right, let's try to put the graph in view. Okay, so here's the ruler. Boom. Okay, start sliding. Okay, if g is currently above, f is currently below, right? And this is now going to stop, right? Because if I've reached one of its x-intercepts, so I now know that f is now going to start going above, right? So I might as well just draw a line, okay? Because g is still going to be above, right? So okay, draw a line, okay? Okay, because I've met one of the conditions, right, where g is positive and f is negative, right? So notice as I carry on, right, f is now above, right, and g is also above. Okay, so still the same until we get to the x-intercept of g, right? F is still above, okay? Now g is going to start going below, okay? So we can actually rule a line because now they're going to be in opposite sides again, okay? Okay, so here we go. F is above, G is below. That's opposite sides. Still in opposite sides. Okay, we've reached another x-intercept, right? So this x-intercept is telling us that G is now going to start going above, right? And F is still above, okay? So we can actually rule a line because now they're going to be on the same side. Okay, so we're not interested in that. Okay, because now they are on the same side. Okay, right. So if we try to summarize, right, we've basically identified the opposite sides as being this region over here, right? So this region, okay, if I roll it off again, okay, so this first region, you can see G is positive, right, and F is negative, right? So that's this condition here. G is positive, F is negative, right? And then we also identified this region. Okay. Why? Because in this region, F is above until it gets to that point, right? So F is positive and G is below. Okay, G is negative, right? So we basically have that condition. Okay, so let's shade our regions in. You don't need to shade them in. I just want to help you to focus. Okay, so I've basically shaded in our two regions of interest, right? Let's just get you to convince yourself, right? Let's take away all the clutter, right? So that's the first region. Okay, you can see they are on opposite sides, right? One is below the x-axis, the other one is above the x-axis. Okay, let's look at the second one that we identified. Okay, you can see again the one is above the x-axis and the other one is below the x-axis. Okay, so hopefully this helps you to convince yourself and to really just focus in on the regions of interest, right? Like I said, the most difficult part of graph interpretation is to try to ignore the extra things that are going on around what you're trying to concentrate on. Okay, so unfortunately in reality, this is how it's going to look. Okay. Right, so now I need to add another element over here because we have a division over here, right? We need to worry about this whole situation of dividing by 0, okay? So whenever, right, you are looking for this condition where you're looking at a division, right, take this function that is in the denominator and exclude immediately, right, where that function is equals to 0, okay? So the function g is our parabola, right, and it is equals to 0 here, right, at this x-intercept of 2, 0, right, so we're going to immediately exclude that x value of 2, right, so we're not going to include it. Okay, where else do we have g being equal to 0? Well, we have g being equal to 0 here as well. Okay, at its x-intercept, we actually don't know what that x-intercept is, right? But we do know that it's the same x value as the x value at the turning point of f, okay? But either way, we don't want that x value either, so we're going to exclude that one as well because it's a division by 0, okay? So we can even, I want to write down a skeleton coordinate, right? So we just need the x value there, but we know that the y value there is 0. Okay, so we're looking at this first set of solution, okay, and in this one, okay, the 0 in this case is with the graph of f. F is not in the denominator, so that's fine. We can include that x value of -2, that is okay. And then we're looking at all these other x values before this. Okay, right. So now we've actually realized that there is something else that we need to calculate. So we just grab the equation of f. And we actually also have the equation of f prime, right? So that we can calculate the x value over there, right? We're going to take it in terms of calculus, in terms of calculating the x value at the turning points. We know that the x value at the turning points, we find it, right, by setting the derivative equal to 0, right? So we're going to say, okay, for x values at stationary points, okay, we're going to set f prime of x equal to 0, okay? So f prime of x is g of x, so g of x equal to 0, which gives us 6x squared, okay, minus 8x minus 8 equal to 0, okay. Right, so there's a common factor of 2 over here, right, so we can divide through, right, here by 2, okay, so that will give us 3. Just move, I think I can move this one out the way. Okay, so it will give us 3x squared, right, minus 4x minus 4 is equals to 0. Right, so we can use the information on the graph to help us, right, because we already know that the other turning point is here at an x value of 2, right? So we know that one of the factors over here has to be x minus 2, right, just to help us to factorize this. So we can now work backwards and say, well, if we want a minus 4, then we need a plus 2 over here, right? That is going to give us the minus 4, right? And then for the 3x, we just need, for the 3x squared, we just need a 3x over here, right? So let's just check. Right, we're going to have 3x squared, and then we're going to have negative 6x. Right, so negative 6x plus 2x will give us the middle term of negative 4x, and then last term of negative 4. Okay, so there we go. Right, so we're not really interested in this second bracket. We are more interested in this first one. Okay, so we're going to have, therefore, 3x plus 2 is equals to 0, or x minus 2 is equals to 0. We don't care about this one. We know about it. We're more interested in this one. 3x is equals to minus 2. Therefore, x is equals to minus 2 over 3. Sorry, you can't see. Right? Okay, so going back to our sketch, this unknown x value there, which is the x value at the turning point, is minus 2 over 3. Okay, so we can now take this away. Putting the graph back in view. We can now write down the answer, right, to B. Okay. Okay, so yet again, solution. This is for B, right? So then therefore, f of x divided by g of x is less than 0 when, okay, let's look at our regions, right? We're looking at x values, right, less than negative 2, right, and including that x value. Okay, so we're going to have x, right, is an element of starting, basically you're going to write it coming in this way. Okay, so we're going to have negative infinity up until we get to negative 2, and this time that is included. Okay, and then for the second solution, this one over here, right, we already stated that we're not including those two x values, so it's open bracket negative 2 over 3 up until an x value of 2. Okay, so that x value over there. Okay, and there you go. Right, so that is the solution for B. Just remind you, for the solution for A, okay, if you just need a reminder, for A, right, we first started off by finding the equation of f, right? So that required us to calculate the value of a first, and we did that. And then once we found the value of a, we substituted it back into f of x to get the equation for f, and then we had to find the equation of g, which was f prime of x, and then from the equation of g we got that y-intercept, right, the value of the y-intercept. Okay, and then this was a. Okay, therefore f of x minus g of x is equals to 24. Okay, the distance of 24 when x is equals to 0. Okay, right.